Hello learners, welcome to Neenv IAS. Today's session is on concept based in science and technology, particularly astrophysics. We are going to see little topics, but they are extremely, let's say, important to the structure of universe. They will tell us how we can understand the universe, right? So let us start. Right? So in the introduction, we need to understand the overall scenario, let's say a bird's eye view. All right. So scientists were making observations around the universe, right? So they saw that some things are happening, but they could not understand the reason for it. So they theorized that something exists and they affect the universe in some manner. Now I know I am not being very particular because we are going to see those things one by one, right? So scientists were making an observation. They were like, this we are observing something and it should happen in the way we are predicting because our theory is right, but something else was there which was not theorized while observing. So they named those things as dark matter and dark energy, right? So these two things cause mysterious influences. They cause mysterious influences, and the one thing which stretches the universe, it is called dark energy. And another influence which causes clumping, that means it brings matter together, it is called dark matter, right? What are the characteristics? See, they cannot be seen or touched. That is why they are mysterious. They are not seen, and I'll explain you how it was detected. We'll discuss the evidence also, but please understand they cannot be seen. All right. So they are hypothesized. That means it is guessed. It is guessed that something exists like that in the universe which is causing this effect which we are seeing. Right. What is the evidence? Of course, there is no direct evidence. That is why it is mysterious. It is named as dark energy or dark matter. All right. So there is no direct evidence for this, only observation. Like I told you, scientists were observing the universe according to the current theory, and their current theory, like in the 1970s, they started learning about these matters and this energy. So they were exploring the universe, trying to observe it according to the prevalent theory at that time, and they realized that something is happening which we are not able to understand. All right. So these are the universe building block. Universe's building block. That means first is matter, second is dark matter, third is dark energy. Now, what do I mean by building blocks? I'll share in the next slide. I have a good diagram for you. See, what is matter? Before understanding anything, before understanding visible matter or dark energy, we should understand what is matter. Basically, anything that has mass and occupies space, it has mass and occupies space, is called matter. Right? So it includes what? It includes everything that we can see. It is basically whatever we can touch, right? Or anything that occupies space, right? From people to planets, right? But there is something beyond visible matter which is called dark matter. Right now we are trying to understand only matter and its subtypes, visible matter and dark matter. All right. So dark energy and dark matter, like I said, are mysterious substances influencing the cosmos. Now sometimes you will find that I have discussed something and it is written after we'll see what is written. So I am trying to not duplicate the effort. So quickly I will read, but of course I'll explain everything that is written. Right. So what is the energy and mass distribution in the universe? Energy and mass. All right. So dark energy is around 68%. This is not exact. It can go up to 72% in some scientific articles. Dark matter is around 27%. Visible matter is only 5%. Visible matter means whatever we can see. Even these big galaxies that are there, big planets, big stars, whatever we can see, that is only 5% of the universe, and that is mind blowing. All right. So what are the conclusions you can draw? Universe is not constructed of atoms alone, because we can see atoms. So atoms are only 5%, in part of 5%. Secondly, empty space that is out there is not empty because it has dark matter and dark energy. All right. So what are the components we have seen? Correct. Now, why it is called dark? All right. Now, it is not dark because it is an evil thing. The point is, we cannot see it. Dark matter does not interact with light at all. It exists. It has a gravitational influence also around its, let's say, wherever it exists, wherever it occupies the space. But it does not have any interaction with light. Hence, it is termed as dark. We cannot see it, right? It neither emits, absorbs, or reflects light, right? Hence, not observable by our telescopes. This is the issue. But I'll tell you how. It is very interesting how it was found out. So it does not mean it is evil. Okay. So how was it found? We'll see that later. Okay. And this is a very important thing to understand, that something which is very far and cannot be seen is still observed, right? Okay. So the first thing, what is normal matter, what is visible matter, or what is baryonic matter? UPSC tends to ask synonyms, like I've told you before. So that's why I bring all the available synonyms that are there. So visible matter is, of course, whatever we can see. It is also known as baryonic matter. Baryons are subatomic particles like proton, electrons, and neutrons, right? So visible because we can directly observe them. It is seen under visible light, and through our telescopes we can detect it. Okay. It is made up of atomic particles, right? It can exist as gas, solid, or liquid. We all know about this. This is very simple. It is only 5% of the universe, right? Next, dark matter. Now we come to the meat of the topic, which is dark matter. Now, what are the characteristics? Although we have understood what is dark and what is matter, I have explained the terms to you. Now let us understand the phenomena. So what are the characteristics? Of course, it takes up space and mass because it is a matter. It is only observed. It is not seen. It is observed by its gravitational influence. For example, let's say you are sitting near a pond, and slowly the waves come towards you. Let's say the pond was still, right, when you started sitting over there, and when you sat for, let's say, 10-15 minutes, you saw the ripples coming in the water, but you don't know what caused it, right? Similarly, dark matter is there. We can see its effect, but we cannot see what is causing it, right? So it is invisible, not dark or black. So gravitational influence is there. It prevents galaxies from flying off. Okay, it will be clear in the coming slides. So it is essential for galaxy formation. Just understand this right now. Now, what is the proportion in the universe? Around 27%, as discussed before. Now, uncertainty is there for this matter. That means we don't know what is the composition of this matter. Like in atom, we know there is at least neutron, proton, right? Electrons also. So there are subatomic particles, we know, but we don't know what is the particle of dark matter. We don't know. There is no data. It is theorized that there are some particles, different type of subatomic particles. Okay. What is the nature? It is the invisible glue. Now I am giving you a lot of these things, right? So why? Because from film perspective, this is important. They can ask you in any way. It is the invisible glue of universe. Any type of light, any and all type of light just passes through this thing. So it is not opaque, right? It allows light to pass through it. Okay, so it is completely transparent. Like seeing ripples, we have already discussed in the pond, right? So what are the properties in nutshell? This is important for prelims. Please read them. I have discussed everything. All right. Now let us see an artist's image. This has been created by an artist. This is the image which is by the telescope, and this is the artist's image. If we see the blue part, and here there is no blue part, right? So the blue part will be possible how, let's say, possibly how dark matter would look if it was visible, but it is not. It is not in the visible spectrum. Only 5% of the universe is visible. This is not visible. This is just an artist's impression, right? So what is the evidence? Now, like I told you, scientists were observing the universe. So when they were observing the galaxies, they saw something and then they theorized this. So what happened was, see, in our solar system, let's say here is the sun and here is the farthest planet, right? So it is in a orbit around the sun, but the farther the planet from the sun in our solar system, the slower it goes around the sun. So scientists thought that galaxies which are in the outer, area of the universe, or stars which are in the outer area of galaxies, they would do the same. They would go around their center slowly, but this was not happening, right? So they instead, like stars on a galaxy's outskirts were orbiting just as fast, right? But imagine if something is on the outside, and if you rotate the disk, let's say faster, the outside things will fall off. I'll show you one GIF which will make this clear, right? So they theorized that something is holding the things which are on the outskirts. It is holding them together, otherwise they will fly off due to centrifugal force, right? So this discrepancy in observing and the theory, this gap was termed as dark matter, because dark matter is a matter and it has gravity. Any matter that exists in the universe, it exerts gravity. So that gravity is keeping the galaxies together, right? So it has stabilizing effect. Invisible dark matter provides gravity which stabilizes the, here it should be stabilizes the galaxy, pardon me, right? So it's a glue, right? So let us see the example. You can see this, all right? This person falls off the merry-go-round. Why? Because he was not holding on properly. The other guy was holding on properly. So for example, to understand dark energy, we can say the person who did not fall off had more dark energy than the person who was thrown off the merry-go-round, all right? So this is how you can understand dark energy. It is a gravitational, or let's say it's a glue. That means it has gravity which keeps things together. So this this graph, it might look complicated, but let me just explain. So A is the actual observed velocity of the stars, and B is the velocity that was supposed to be. That means this was the theory by which the scientists were observing. That means they said that, okay, this should be the speed of the stars if it is very far from the center of the galaxy, all right? So it should be slow, just like our planets are revolving around the sun slowly as they are farther from the sun. But this did not happen. So this was correct. Till here it was correct. But from here, the observance of the phenomena changed the theory, right? So this data indicates there is large amount of mass in the outer part also, which is giving the gravity, okay? But it is dark because it is not interacting with light. This is important, right? So I hope you understand this. What is the second evidence? Again, while observing the universe, there were some things that were found which led to the theorization of dark matter. How? See, every mass has gravity and dark matter also has, every matter has gravity and dark matter also has a gravitational pull. So what happens is, it distorts the images of galaxy, right? So let's say our telescope is there, it is observing a galaxy, right? And in between there is something, let's say dark matter. So telescope, dark matter and the galaxy that we want to observe. So the light coming from the galaxy, it is distorted because of the dark matter. So our photos in telescopes are not clear. So we were confused. Scientists were confused. Why this is happening? So they theorized that there is a dark matter. So this is the second evidence, right? So this is called gravitational lensing. This is the keyword. This is the key term. Please note it down. So it amplifies the light from background objects, acting as a magnifying glass. cosmic magnifying glass. Do you remember in science experiments, there is a magnifying glass that is given to the students so that they can concentrate the sun rays and let's say burn a paper. Similarly, it acts like that. All right. So this allows astronomers to observe faint or distant objects that would be otherwise invisible, because due to dark matter's gravity, it amplifies the light rays coming from behind and it gives light to our telescope. Okay. So limitations of our telescopes are removed because of dark energy. So this is a benefit that we get. All right. Now let us understand it through a diagram. Let's say we want to observe this. This is the object we want to observe, right? And this is the galaxy that is in between us and this is our telescope, us and the thing we want to observe. This is in between. This is the obstacle, right? But the best thing is, due to gravity exerted by dark matter in this galaxy, the light rays are being bent. As you can see, they are being bent and sent towards the telescope. Right? I have another diagram. See, this is the galaxy we want to observe. Now there is a galaxy in the center which has a lot of dark matter. So it is bending the light towards, right? Distortion is observed, and this is how then let's say there is our telescope over here. Okay. So light comes and we see it. But if there is no dark matter, then the galaxy will send it light rays and it will go away from our observation point. There will not be any distortion, but we will not be able to see the galaxy that is behind. Okay. Excuse me, I don't know. Okay. Just a second. Why is this here? Right. Anyway, the observation of Einstein rings. This was let's say created because of the distortion caused by the dark matter. So this is the galaxy which has dark matter, and this image is the image of the thing that is behind this galaxy. So this is how, it's amazing. Another pattern that is created is the cross, this cross. Now this is the center and this is the dark matter's presence. Behind this there is something, and because of the gravity of dark matter, 4 images are created which we can see through our telescope of the thing that is behind this, right? So these 4 images are created of something that is behind this center object. All right. Briefly, let us see the history very quickly. Not really important, but we need to understand something, that it was recently discovered in the past 2-3 decades, 4 decades. Okay. So in 1930s, Swiss astronomer Fritz Zwicky, he coined the term dark matter because he was studying the Coma galaxy cluster. He noticed that galaxies were moving faster than they could be explained by the amount of matter that we could see. Remember, the matter we could see, that was the theory. We thought that whatever we can see is the universe maximum, but turned out dark matter is more than that. So what is it made of? We don't know. Composition we don't know. And if we, let's say, knew and we could see, universe would look very different. How? It would look like the blue picture. Remember the blue picture? And so it will look like a web. Now one fact for you, since in prelims 2023 UPSC asked something related to stars, they might ask something like this also, which is confusing, because dwarf galaxies, which are smaller ones, they would UPSC can ask if they have higher dark matter or lower. They have higher dark matter. Okay, remember, they have higher dark matter. They can compare it with other stars like supernovas and all. So remember this. Similar question came in UPSC 2023. Now let us move on to the second topic, which is called dark energy. I have put this wanted poster because we don't know how dark energy works. It is more mysterious than dark matter. At least we understand the properties. Here we understand lesser properties. So dark energy is around 68% of the universe, right? Like I told you, there is a huge knowledge gap. We don't really understand this, and we understand it lesser than dark matter. right? And it was an unexpected discovery because scientists thought that universe was expanding, but it was slowing down. But they turned out to be something else. I'll explain later, right? So since 1920s, astronomers have known that universe is expanding, but in 1990s, observation was there and it revealed the opposite, that universe is not expanding, not just expanding, but it is speeding up. The expansion is accelerating, right? A diagram will come and I'll explain it, don't worry. So acceleration started around 5 billion years ago. So this is the observation. They thought that gravity, Big Bang happened, right? So Big Bang happened and there was blast and it threw stuff everywhere. Slowly planets, stars developed. So they were expanding due to momentum. But since everything that has mass will exert gravity, that gravity was theorized to bring everything closer together and, right, big crunch would happen. We'll discuss that. The point is, this did not happen. They thought that things will slow down, right? But they observed in 1900s that it is not slowing down, but it is still going on. Okay, universe is expanding, but now we know that it is not just expanding, but the speed is also increasing. And the reason for that speed is dark energy. So the cause of the accelerated expansion is dark energy, as named by Michael Turner in 1999. All right. So how would you define it? It's a hypothetical form of energy, because of course we are observing something and then we are telling, okay, there is something. Usually what happens is we go from theory to observation, but here we are going in the reverse manner. Second point, proposed to explain the accelerated expansion act as anti-gravity force. Why? Because it is accelerating the expansion, right? Current state of knowledge is that we have limited understanding of its nature and properties, why it is there, or what is it made up of, can we stop it, we cannot even see it, right? So we cannot even design experiments that we can check it with. We don't know its nature. So how will we define an experiment? We cannot know the parameters. So research is going on, right? Now big crunch, I just said briefly what is big crunch. So first Big Bang happened and Stephen Hawking said things will slowly come back to the point where Big Bang happened, right? And it will be called a big crunch. So universe will expand after Big Bang and then it will slowly crunch because of gravity. So astronomers observe the expansion, right? Galaxies are moving away from each other, suggests that in the past Big Bang happened, right? They are moving away from each other. That means sometime earlier they were closer together. So they assumed that gravity of all the cosmos and galaxy would be slowing down, right? It was thought that universe might someday collapse back on into itself, leading to big crunch. This was told by Stephen Hawking. So this is how it might look. They will combine together to form a large energy, right, to a point. So this is how it might look. So Big Bang happened, things expanded. After a while, momentum would slow down, and due to gravity, everything will go back to big crunch, right? So some questions, and please ask yourself also these questions whenever you are making notes about any topic, not just science and technology. So how do we know the expansion is driven by dark energy and isn't connected to the Big Bang? See, Big Bang said blast, spread out, things will go, momentum will die down slowly, things will come back. But things are not slowing down. They are accelerating. It is expanding. Let's say we are not in the point where expansion is slowing, but the expansion is not just looking to like get, it will not become slow anymore. It is accelerating. So how do we know? Because Big Bang theory does not say that there is an accelerated expansion. The current state of expansion is not constant. If it was constant, then it was Big Bang related. Why it is so mysterious? Because we can't measure it. Okay, we cannot know its composition right now. We don't even know what it is made of, like I said. So it is hard to detect it, and you cannot tell your telescope what to see because we don't know what to see, right? And why it is important to understand dark energy? Because it makes up to 68% of the universe. So we need to understand how universe works, and for that we need to understand this, and where universe is going, how it will end, and what is the past. For all that we need dark energy understanding, right? So let us take a simple analogy. Let's say you buy a balloon, it is not inflated, that means it does not have air right now, it is deflated. You draw 3 dots on the balloon, 2 closer and 2 a little, one a little farther. Then you start filling up the balloon. So when you start filling up the balloon, it will expand, and then the third one, which was already farther away, it will quickly go away from these 2 dots. So in this analogy, the deflated balloon is the early stages after Big Bang, just after Big Bang. Spots are galaxies. Breath from which you will fill up the balloon, it is the dark energy. And the rubber which the balloon is made up of, it will exert some pressure, that is the gravity of the galaxies, right? But we fill it, despite the tension in the rubber, we fill the balloon, and that is the same thing that dark energy is doing. Despite the gravity exerted by the parts, it is still expanding. Okay, right? So farther spot, it will move more rapidly, you can do it. Okay, now this is important. See, dark energy is faster than light. UPSC can just put this in an MCQ and tell you that is it true? Yes, it is true. Okay, it was known by observing a galaxy called Gen Z 11. Okay, let's move forward. So now understand this thing. Okay, this is the Big Bang. Things started, they were blasted off, things started expanding, slowly galaxies were built, and here, somewhere here, 5 billion years ago, dark energy started the accelerated expansion. Okay, slowly things are expanding for sure, but according to Big Bang theory, the momentum should slow down, right? So this is how it will look. Again, let's say Big Bang 10 billion years ago, deceleration started, that means the expansion speed was slowing down. 5 billion years ago, acceleration increased, and this is here we are today, it is increasing. So this is the issue. So what is the evidence? Now again, there is a term here, redshift. Let me explain. See, what happens is, let's say here was the Big Bang and the galaxies started developing at this point. So, and let's say we are at this point, and we are now observing a galaxy here, right? From our telescope, we are observing it, right? We are observing this galaxy, but the point was, we expected the galaxy to be at point A, but it was at point B. Okay, we expected the galaxy to be at point A, but it was at point B, and this was known because of the light that was coming from the galaxy. Now what happened was, whenever light comes from a closer source, it is lesser red in color. As the source moves away, right, source of light moves away from the observing point, the light gets redder and redder. So this is called redshift. The farther away the source of light is, the more red its light would be. Okay, so this is called redshift, because wavelength of the rays, light rays, increase as it travels more. As the light is traveling more, its wavelength increases and it goes towards red. So the further away the light source, the more light is redshifted. So what happened was, scientists were observing supernova explosions, and they saw that they were fainter than expected, indicating that they were farther away than predicted. Like I said, they were predicted at point A, but they were found at point B. Now this suggests that expansion is accelerating, because according to our theory and calculations, we thought that we would see them at point A. Okay, but it is accelerating, hence they were found at point B. So redshift is related to dark energy. Dark energy now versus dark matter. See, what is the similarity? See, both are mysterious and poorly understood. Neither can be directly detected. Their existence is inferred from their effect on visible matter. Visible matter we can see. We have no, let's say, tools to detect dark matter or energy. Now, what is the key difference? See, matter, dark matter is a form of matter. Energy is just a energy. It is not a matter. It will not exert gravity, right? So dark matter exerts gravity. Dark energy is a repulsive force. Dark matter has gravity. It will pull things together. Dark energy will throw things away, right? So there has been a cosmic tug of war that is going on between these two, dark matter and dark energy. Dark energy wants to pull the universe away, and dark matter wants to push down the galaxies, right? You can see it is a weight. Dark energy is a balloon, so it is picking up. It wants to take things away, and right now it is happening. Dark energy is winning, right? So that is all for this mysterious topics. I hope you enjoyed it as much as I liked researching about it and teaching it to you, right? So if there is anything, let's say feedback or any doubt, please let us know in the comment section. Thank you for your time. Thank you for listening.